Today we shall discuss some typical examples on complex number. The first problem is the solution of the system of equations real z square equal to 0 and mod z is equal to 2 is we are given options, 4 options are given. Which one is correct? You have to detect. The solution of the system of equations real z square equals to 0 and mod z is equal to 2. This is first problem. Now, in the case of complex number, we know that first we take z is equal to, let z is equal to x plus iy. First we take that z is equal to x plus iy. Next, we write down two equations. One is real z square. So first we find z square. What is our z square? Z square means x plus iy this whole square. That is x square minus y square then plus 2i xy. So what is the real part? In case of the complex number, z is equal to x plus iy. What is our real z? So real z is equal to x. So what is our real z square? So real part of z square, that is our x square minus y square. So first equation will be x square minus y square. X square minus y square equals to 0. This will be the first equation. And what is the second equation? Mod z is equal to 2. Modular subject means this will imply root over of x square plus y square. Root over of x square plus y square. This is equals to 2. And this implies x square plus y square equal to 4. X square plus y square equal to 4. Next, you have to solve these two equations to find x and y, and therefore you have to detect which of these options are correct. So, details of the calculation given on the next page. So, from equation number 1, we have got x is equal to plus minus root 2 and y is equal to also plus minus root 2. So, z equal to this one. So the correct option is D. Next problem is, let z belongs to C, that is set of complex numbers, such that mod z less than 1 and you are given if w is equal to 5 plus 3z by 5 into 1 minus z whole square, 5 into 1 minus z, then you want 4 into imaginary z greater than 5. 5 into real part of w, that is greater than 1. 5 into imaginary w less than 1. 5 into real w greater than 4. You have to detect which one is correct. So what you are given? You are given w is equal to 5 plus 3z by 5 into 1 minus z. So after cross multiplication, what do you get? Z in terms of w, we have got z is equal to 5 into w minus 1 by 5w plus 3. Why you have got z in terms of w? As because you are given mod z less than 1. So put here mod z less than 1. So this will imply this is 5 into w minus 1 less than 5w plus 3. So from this equation, you can w minus 1. If w is equal to x plus iy, then w minus 1 is equal to x minus 1 plus iy, and 5w plus 3 is equal to 5x plus 3 plus 5iy. So from 1 we get 5 into this equal to, we are squaring both sides, what we get? This implies this. So minus 50x plus 25 is less than 30x plus 9, therefore 5x greater than 1. And what is our x? Real part of w. So 5 into real part of w, this is greater than greater than 1. Next problem, a complex number z is said to be unimodular. Unimodular means modulus of the complex number is 1. So a complex number z is said to be unimodular if mod z equals to 1. Next, if z1 and z2 are complex numbers such that z1 minus 2z2 by 2 minus z1 z2 bar. Z2 bar means that is conjugate of z2 is unimodular and z2 is not unimodular, then the point z either lies on straight line parallel to x-axis, straight line parallel to y-axis, circle of radius 2 and circle of radius root 2. So just first we discussed that unimodular means modulus of z equal to 1 and not unimodular modulus z is not equal to 1. So given that z2 is not unimodular, that means mod of z2 is not equal to 1. Also given z1 minus 2z2 by 2 minus z1 z2 bar is unimodular. And just we discussed what is a z2 bar. That is conjugate of the complex number. Conjugate of the complex number z. If z is the complex number, z equal to x plus iy, and what is our z bar? That is conjugate of z. Z bar is the x minus iy. This is the conjugate of z. Now you are given this equal to this is unimodular. That means modulus of this z1 minus 2z2 by 2 minus z1 into z2 bar is equal to 1. So we can write mod of z1 minus 2z2 this whole square is equal to 2 minus z1 into z2 bar this whole square. Just now we have written here z into z bar is equal to z square. How is this? Z into z bar. That means z into z bar means this two multiplication, that is x square plus y square. And what is our modulus z? Root over of x square plus y square. So we can write this as mod of z square. So here z1 minus 2z2 is whole square. So we can write this is the complex number z1 minus 2z2 and take its conjugate, that is z1 bar minus 2z2 bar is equal to 2 minus z1 z2 bar. This whole square means this complex number multiplied by its conjugate. So z1 conjugate and then into z2. Why it is? That is we can write that z1 into z into here we have taken this is a z1 here 2 minus z1 z2 bar into 2 minus z1 bar z2. That is z bar of bar is the complex number itself, and that's why we have written here 2 minus z1 z2 bar into 2 minus z1 bar z2. Next we multiply both sides, and after cancelling the brackets take common mod z1 square 1 minus mod z2 square minus 4 into this 1 minus mod of z2 square. So factorizing this 1 minus mod z2 square into z1 square z1 whole square minus 4 equal to 0. You are given that mod of z2 is not equal to 1. So this factor, that is this factor is not 0. As z2 not equal to 1, mod of z2 not equal to 1, so you can write 1 minus mod of z2 square not equal to 0. Therefore, mod z1 square minus 4 equals to 0, and that form you can write mod z1 is equal to 2. What is our mod z1? Let's the complex number z1 be x plus iy. Mod z1 is equal to 2 you are given, that is root over of x square plus y square equal to 2. So we can write x square plus y square equal to 4. So z1 lies on a circle with center 0 0 and radius 2, as because x square plus y square equal to r square means is the equation of a circle with center, origin and radius r. So here this lies on the circle whose radius is 2, so the correct option is C. Thank you.